Hello everyone, for this tutorial video I'd like to explain how to find related rates of change, as opposed to rates of change of only one function. Related rates of change are called so because, although there are different rates of change happening at the same time, they are related to each other, and are not completely independent. For example, if we were told that air is being pumped into a spherical balloon at exactly 5 cubic centimeters per minute, and as to determine the radius is increasing when the diameter is exactly 20 centimeters. We do this by first noticing the rate of change of volume is given explicitly as 5. So what is a mystery in this problem is figuring out the rate of change of radius. But we do know that we want to solve for the rate of change of the radius exactly when the diameter is 20 centimeters, which means logically when the radius is 10 centimeters. If you have memorized your geometry formulas, you would know the volume of a sphere is 4/3 pi times r cubed. So now we take the derivative with respect to t on both sides, and this is an application of implicit differentiation. So we factor out the 4/3 pi as it is a constant, and do 3r squared times the derivative of r. So now the 3 and 4/3 and the 3 and 3r squared cancel each other out. And now we plug in the appropriate dimensions for the rate of change of volume and also the radius. And once we do some arithmetic and algebra, we should logically conclude that the rate of change of radius is exactly 1 divided by 80 times pi centimeters per minute. Now that we have figured out how to solve problems involving related rates of change in addition to rates of change of one function like we saw in the previous two videos, we can move on to another application of derivatives in the next video that is more obscure/specialized, which is something known as L'Hopital's rule, and is used to find the limits of functions that have indeterminate form. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.